Hey, so in this one, we're going to be going over functions. This is a mini lesson. Most of your projects are function based. So if I go in and look at these projects, let's take a look at the string class, for example. Let's look at getting digits. So this one says overview, given an integer, return the number of digits it has. So when we're thinking about, let me pull up Paint. When we're thinking about a program that we have to write, we have to think about inputs. Let me make this bigger. Inputs and outputs. Okay? So the goal is to take the input, put it through some transformation, and we get the desired output. Okay? So by output, we don't just mean printing to the console, which is stuff like system out print line, right? This is printing out to the console. That's not always what we mean by output. This is output to a user, but to us as programmers, output can mean simply applying some function, such as say we have a function that takes some number x and adds 3 to it. So in this function, we take x and we add 3, right? And we can return that number. And this is the output of the function. X is the input, x plus 3 is the output. And I'll show you a little more in depth what I mean by this. But by making functions, that's OBS, by making functions, we can compartmentalize our code and make it easier to debug and read and maintain and grow it. So just as an example, let's take, let's say we have some function called, let's do print high. So this function does absolutely nothing right now. Public static void print high. And there are two reasons it does nothing. The first reason is because there's nothing in the body. We've declared this function. We've given it a name. We say it's not going to return anything. It has no parameters. And it also doesn't have any body. It doesn't do anything when we call it. And the second reason that it doesn't do anything is because we never actually called it in our program. So when you start a Java program, it starts in main and it runs from the top to the bottom of main. No more, no less. So I'm going to just run this and nothing's going to happen. I'm going to call this function print high. And when I hit run, the program is going to see, Java's going to see that in our program, we have a function call. This is the declaration. We've said, we've made this function. This is the blueprint of the function. Whenever you see this function, hop on down to this code and run it. So if I hit run here, it also does nothing, but it did jump to our function. So it jumped down here and it ran the code, which there's nothing in there. So instead, let's put some print statement in here. Let's say, yo. When I hit run, it prints yo. So the program started here, hit this line. Java said, oh, this is a function. This is a function that the user has created. So I need to jump over there to wherever they created it, and I need to start running that code. So it ran system out print line yo. And in fact, we could call this a whole bunch of times. Ooh, I want to copy this. We can do this a whole bunch of times, and it's going to run the same code each time. Nice. So that's essentially what I'm having you guys build. Is I'm giving you, let's see, where is it? I'm giving you a set of instructions of what you need to do, such as get the digits, get the number of digits, and I give you a template of what you need to do. And there are a couple parts that I need you to memorize for these functions. Okay, this will make your life so much easier when understanding what you need to do for an assignment. So I'm just going to copy this over here. Let's paste this one in as an example. So if I were to call this function, its name is get digits. So I would need to put get digits. Okay? That's all I need to do to call the function. Now, there are there are a couple more things I want to talk about in a function. Functions have a name. Functions have an input, which is in the parentheses. This is the data that you're sending to a function. So in this case, this function takes a number. So I can put any number I want in here. So I'm going to put this number in there. This is the input. So I call the function with some input, 732. And that input gets saved to this variable, num. Okay? This variable num only exists in the function. And this might seem a little weird at first, but as you start to make modular code and you start to make more and more code that does more and more stuff and you want to break it down, having this is called abstraction. Having this level of abstraction makes programming a much easier task. So we have this variable num, and its value is set equal to whatever we pass in. So if we passed this number in, num would have the value this. So when you're using num in your code, you can say something like system out print line, and one of the parameters, num. I'm going to keep this return here for now. You can do something like print out whatever num is. Okay? So we've passed in this value. It gets saved to this variable called num, and then we're going to print out the value of num. 723. Very nice. So every time you call this function, it fully resets. And that's good for us because we don't want multiple function calls to act differently. If we had one like this, and one like this, and one like this, right? We want all of these to do the same thing. When I call this function getDigits, well, it's called getDigits, but for here, all it does is print out the number. I wouldn't want this function call to carry over into this function call. So every time you call it, the parameters and everything gets reset in it. So when I hit run, oops, what did I do? Integer too large. Shouldn't be. There we go. I just had a 0 in the front. So, oh, sorry, hold on one sec. The doctor's office is calling me. Okay, so each time this function ran, it had a different input, and that's the input that got printed out. That's what gets saved to it. And this can be anything. This variable right here, you could call it A. You can call it literally anything. This is an input. You have the type of the input and the input itself. It can be literally anything. It can be an object. It can be a primitive type. It can be a wrapper. It can be an array. It can be literally anything that you pass into here. The other thing that's important is that you can, let me see, which way do I, okay. The other thing that's important to remember is that there's this thing called a return type. You don't have to worry about these two words for now, but this one, this is the return type. Okay, let me map this out for you. So you have the return type. You have the name. And then you have the parameters. Okay? So you can see here, oops, OBS. You can see here that the return type is an int. I'm going to get rid of this this part over here for now, make it a little easier to look at. We have the return type, which is an integer. We're going to send an integer out of this function. We have the name of it, getDigits. And this function takes in an integer. And we're going to call that number that's been taken in num. So if I do this, and I return 42. I'm just going to get rid of the parameter for here. I can make a variable int x. Okay. When you see return, this is the value that gets passed back from the function. So once you're done doing all of your calculations and everything, once you're done with all of your calculations and everything, this is the final value that gets spit out. Okay, and we return it because anything created in a function only exists in that function. So when we call getDigits, it's going to return the value 42. That 42 is essentially going to replace the function call. And you can see here, it ends up being int x equals 42. So I'm going to print out whatever x has. System out print line x. And we're going to see, oops, what'd I do? Non-static, oh, I forgot to add this stuff back in. Public static. It's important stuff, but you don't need to know what it does right now. So we get 42. So when the program starts, it creates a variable called x, and it goes to set a value in it. But the value is a function call. So it hops over to the function, and it runs it. It has no input, and it returns an integer. All it does is say, return the number 42, and that number 42 replaces the function call. And so we get int x equals 42, and we print out the value in x. I know that's a lot. Hopefully, as you do it more and more, it becomes second nature, and you'll be able to look at a function and be like, okay, that's exactly what I have to do. So taking another look at getDigits. Let's look at this. Actually, we'll look at it in terms of the actual assignment. So the overview of this assignment is given an integer, return the number of digits it has. So our input is a number like 110154. And the goal, this is the input, this is an int. The goal is to transform this in some way into another integer that is the number of digits it has, which is 6. So this should output 6. This is the return value. This is what it should return. Okay? It should return the value 6 so that you can do stuff with it in your program. And you can see right here I have inputs. It takes an int, which is called num, and it refers to the number of the number to get digits of. The number that you want to get the digits of. You have outputs, and this is what you're returning. This is also an integer, and I just called it digits for the number of digits. And this is the number of digits in the input num. Here's an example. If you put in 74778, you should get 5 because there are 5 digits. So when we look back at this template, we can see that there's a return 0, which you're going to replace, and you're going to do all of your code in here. And I have my test cases up here because main is the only thing that runs. So a lot of people get confused. They see 3 calls to this function, and they say, well, I have to remake this function 3 times for 3 different inputs. The thing is that you don't. The goal of a function is to make code that is modular. No matter what your input is, it should return the correct output. So whatever I code in here, right, it should work for this number, it should work for this number, it should work for this number, whatever you pass into it, as long as it's not like a string or something that's totally incorrect, right? Any real input for the function. So the first time you call this function, it will run it where num is equal to 99503. The second time you run it, it'll have num equal to this number. And the third time you run it, it has num equal to this number, 4. Very nice. Hopefully that was good. Oh, actually, I tell you what, we'll take a look at one of the first challenges. Let's take a look at, I think most people did divvying cookies. I think this is a good one. We're going to look at the template and then a model solution, just as a quick little thing. So right here, we see that, oh, void is also important. Void means it doesn't return anything. So you wouldn't be able to save this back to some variable, like int x equals divvy cookies, because it doesn't return anything. There's nothing that it sends back. If you were to print out what the value of x is, it wouldn't like that, because there's nothing saved in x. If this was an integer, you could save it to x, but it's void. It doesn't return anything. So this function takes two numbers. The first one refers to the number of people, and the second one refers to the number of cookies. So this function call says that there are 2 people. People will equal 2, and there are 10 cookies. So cookies will equal 10. Now, your code in here should get the, let's see, which one? This one is how many cookies each person gets. So you're going to fill in code right here, right? That essentially does the math. Given some number of people and some number of cookies, it can be literally anything. It could be 10 million people and 10 million cookies, right? It should do the math and figure it out 100% of the time. This function prints out the number of cookies, but you could actually return this. Return cookies per person. And then you could save it back, right? So then I could say int x equals divvy cookies. But this one doesn't have that. This one has no return. It has a void return. So all we got to do is system out println. So let's take a look at the model solution. So this is what I did. I just did some division, saved it back, printed it out, and we're good to go. This has no return type, but it does print something out, and that's the important part. So that is how we are going to do most of our assignments in this class. As we move on, this kind of stuff should become second nature. You see an input, you see an output, you know what to do. Let me see if there's anything else. You got the syntax, you got return types, parameters, modularity. The reason we use functions is so that we can repeat code and do it over and over and over and over and over again, right? Which is super, super useful. If you know what your input is and your output you're going to get, you can just say, computer, do this, and it'll do it. You can make code like in the math class and all sorts of stuff. And we're going to talk about scanners next. So that's it for this. Hope you like this kind of longer lesson and the new look. I'm using OBS now. It's very nice. Alrighty, have a good one.